Greetings, welcome to a short video on 5.46 Student Performance Across Discussion Sections. A professor who teaches a large introductory statistics class, 197 students, with 8 discussion sections would like to test if students' performance differs by discussion section, where each discussion section has a different teaching assistant. The summary table below gives the average final exam score for each of the discussion section, as well as the standard deviation of scores and the number of students in each section. Okay. So the Anova output can be used to test for differences between average scores with different sections. Conduct a hypothesis test to determine if these data provide convincing evidence that the average score varies across some or all groups. Check conditions and describe any assumptions you might make in proceeding to do this test. Okay, so let's chat about this for a bit. So first step in conducting a hypothesis test, of course, is to set up our hypotheses. So the null hypothesis here is going to be that all of the means are the same. So what do we mean by that? Well, if you come back and take a look, there are section 1, 2, 3, 4, there are 8 sections here. So what we're saying is that the null hypothesis says that mu1 through mu8 are all equal to each other. So that mu1 equals mu2 equals ... is all equal up to mu sub 8. In other words, all of the means are the same. The alternate hypotheses, as per usual with Anova, is at least one differs. So now the next thing they're going to want us to do is to come in and check our assumptions here. Okay, what are the conditions for Anova? Okay, so one of the first conditions are, you don't necessarily have to do them in any particular order, but you need to check all 3 of them, and that's the condition of independence. So what could possibly go wrong here with respect to independence? Well, let's think about this for a minute. So you notice that you have these different discussion sections, and students may be allowed, may not be randomly shuffled into those sections. They're probably allowed to sign up for them based upon their schedules. So one of the old cliches is birds of a feather tend to flock together, is that many students of similar academic backgrounds may enroll together in a particular section since they probably want to enroll with their friends. So independence, weak. Okay, so we have weak shot at independence here. Okay, the second thing we have is we need to check normality, and that is we need to go in and check and make sure each of these particular categories are roughly or approximately normally distributed with respect to their scores. Okay, so if you take a look at the size of the different scores or different sections here, we got 33, we got 19, we got 10, we got 29, we got 33, we got 10, we got 32, we got 31. So in the larger sections, that's probably not going to be too tough because they're greater than 30, which is getting down towards bare minimum that we're going to need. But we have some sections that are really small, like section 3 has only got 10, same with section 6. So normality, not sure. Okay, we're going to have to check that. We don't have the raw data. We should make sure we go in and do QQ plots or normal probability plots on each of those. Okay, and the third one is we need to check and see whether or not the variances tend to be equal to each other. And if we look at them, there's actually a fair amount of spread in the variability in these. There is a test for testing these variations. The Anova works for minor deviations from that, but again, we'd probably want to do something, at least look at side-by-side comparative box plots and look at the interquartile ranges to say something about those. So again, with respect to those, the variability, you're not sure. Okay, so what I'm saying is this is probably not the best test to be using with this data. There are other tests that we could be conducting that are beyond the scope of this class to see whether or not these averages were different from each other or not. Okay. Non-parametrics is in particular what I'm talking about. Alrighty, so, but let's soldier forth. What else did they ask us to do here? They said check the conditions, describe any assumptions you make, and then proceed with the test. Okay, so even though we're saying not such a good idea, we're going to proceed with the test anyway. So what we saw in the previous problem is that the key numbers you need out of the Anova table are the F statistic and the p-value. Remember, the F statistic or the F value comes from the ratio of these two numbers. If you take 75 and divide it by 40.13, you'll get that. These numbers come from the sum of the squares. divided by their degrees of freedom. In other words, if I take this number divided by 7, I'll get back 75. And if I take this number, the 7,584.11, divide that by 189, I'll get back 40.13. Okay. Again, beyond the scope of this class to calculate those by hand. In fact, you probably would never want to do that anyway. So as I said, those are the numbers that we really need to actually conduct a test. So what do we need those numbers for? Well, if we were to give ourselves just a representative F distribution here, okay, and remember that this F value is the ratio of those values between mean square group and mean square residual, and we see that the corresponding F statistic was 1.87. Okay, so 1.87, say right about in that neck of the woods, and then this corresponding shaded region right here, that's going to be our p-value. All right, and notice that the p-value turned out to be 0.0767. Okay, which is equal to 0.0767, which is what? That's greater than 5%. So we would end up failing to reject the null hypotheses. All right, now I'm going to let you finish this part. You need to give me what that means in terms of the problem. What does fail to reject mean with respect to the actual problem that we're working here? Don't just say fail to reject. You got to put it in context. What does that actually mean? What would you tell the folks about the sections is about whether or not they're the same or they're different? Okay, well, hopefully that helps you out. Get going on this problem. We'll be back for more later.